So this question is from page 385 of the textbook. It's question number 7. So the question reads, suppose that 65% of the families in a town own computers if 8 families are surveyed at random. So we start off with A, which is what is the probability that at least 4 own computers? So we start off writing our information. So P is the success, which is 65%, or 0.65. Q is the failure, which is 35%. And N is the number of trials, which is 8, because we're choosing 8 families at random. So using the probability binomial distribution formula, you would write what you're solving. So in this case, at least 4 families own computers. So that would equal 1 minus the probability of no computers, minus the probability of 1 computer, minus the probability of 2 computers, minus the probability of 3 computers. Then you would have 8 choose 0, because you're solving for no computers, times the failure, which is 0.35 to the power of 8. Times the success, 0.65 to the power of 0, because there's 0 families that have a computer. Then you would do 8 choose 1, because you're solving for 1 computer, times 0.37 to the power of 7, 0.65 to the power of 1. The success goes to 1 because 1 family has a computer, which leaves 7 failures. And then you would just follow and do the same for 8 choose 2 times 0.35 to the power of 6, and 0.65 to the power of 2, and 8 choose 3 times 0.35 to the power of 5, and 0.65 to the power of 3, which equals 0.89391, and don't forget a rounding dot, and a therefore statement. So therefore, the probability that at least 4 families own computers is 0.89391. So then for B, it asks what is the expected number of families with computers. So you're going to use the expected value formula, and you multiply n times p. N is the number of trials, so it's 8, and p is the success, so 0.65. So 8 times 0.65 equals 5.2. And then a therefore statement, so therefore the expected value of families with computers is 5.2.